We'll proceed on gradient vector and we will take up 3D. We have seen y calculus, we have seen how calculus, y calculus, okay, so we have seen y calculus and we have seen how calculus. Now idea is that what is differentiation? We know what is differentiation. Differentiation is nothing but algebraic division. Algebraic division in a way that it is not directly gx by x that we have been talking about. If there is a function fx and its integration is gx, then gx by x, that is algebraic division, fx into x is gx, fx into x, that is algebraic multiplication, change into calculus integration, then it brings gx by x, that is algebraic division modified into into calculus, and then it is back into fx. So gx by x is algebraic division, dgx by dx is calculus differentiation. So numeric to algebraic and then algebraic to calculus. So differentiation of gx is called dgx by dx. Division of 10 with 2 is 10 by 2. Different division of gx with x in algebra is gx by x. Now differentiation is is calculus algebraic division. So that is dgx by x. dgx by x, if I do, it goes back to fx. Now this is now we know that through integration I can calculate the net collection from rate of collection, that is gx fx to gx, fx to gx. Okay, then differentiation is from collection back to rate of collection, from gx to fx, dgx by dx. Then not only that, then we saw that if I have a function, if I have if I have x-axis, if I have x-axis, okay, if I have x-axis and function over x fx equal to x square, x-axis and function over x is fx, that is x square. If that is the case, then dy by dx, y equal to fx, y equal to fx, y equal to fx. If that is the case, then this is, if this is x, if this point is x, then this is fx. If this point is x, then this is fx. This is y. If this is x, this big is x on x-axis, rather I can say I vector. Okay, if this is x, then this is y. Fx equal to y equal to fx. What is dy by dx? dfx by dx. Then if x corresponds to this point here, then this point is x comma height y. This point is x comma y. At this point, dfx by dx is tangent. This is called gradient. This is called gradient. Okay. Now, if I have a y equal to x square, y equal to x square, then it turns up into x square minus y equal to 0. X square minus y equal to 0. If that is the case, then if I do differentiation partial derivation with x and y, considering one is along I vector and one is along j vector, if I turn it into vector, I can call it vectorization, but it is not direct vectorization. So it is differential vectorization. It is also called vector field, very famous vector field. If this is vector field, then vector field for x square minus y equal to 0 is 2xi minus j. X square differentiation is 2x and differentiation of y is minus, y is 1. So x square minus y equal to 0 if I calculate the partial derivative, and then 1 d fx d of x square minus y by x along I vector, and d of x square minus y along j vector, then it is 2xi, then it is 2xi minus j. What is means x square minus y by dx is 2x, and x square minus y by dy is minus 1. So in vector notation it is 2xi minus j, 2xi minus j. If that is the case, then 2xi minus j is called, it is called gradient vector. If y equal to x square, then dy by dx equal to 2x. 2x is called gradient, whereas 2xi minus j is called gradient vector. So what is gradient vector? 2xi minus j. As we go along x-axis, then the component of the vector, that is 2x, will grow rapidly, whereas y vector, j vector, is always minus 1. When if y equal to x square, when x equal to 0, then the gradient vector is minus j, like this. If x equal to 10, the gradient vector is 20i minus j, more or less flat. This proves that gradient vector is perpendicular to the surface. Can you see? Gradient vector is perpendicular to the surface. Now, if I consider this y equal to x square, any point x comma y as a position vector, if this is x-axis, what we have discussed, if this is origin, if this point is origin and this is x comma y, if okay, if this point is origin and this is x comma y, then from origin, if I draw a line that is p vector, position vector, then position vector is xi plus yj, xi plus yj. If that is the case, then xi plus y means x square, xi plus x square j. If I go with the, anyway, now I have a in vector representation, this is more loosely, it is called parametric vector. If it is ti plus t square j, then it is parametric vector. Since it is passing through origin, it is full-fledged parametric vector, ti plus t square j. This we can say that representation representation of uh, 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 algebraic curve on representation of algebraic curve in a vector form, xi plus xi plus x square j, xi plus x square j. If this is the position vector at any point x comma y, then if I go with the gradient of this vector, then it will become I plus 2xj, I plus 2xj. This proves that if I go along x-axis, then gradient vectors I is always xi plus x square j, I plus 2xj. This proves that the gradient vector will rapidly it will rise in y direction. So if I have a position vector that is xi plus x square j, I took example as x equal to 10, then it is 10i plus 10 square 100j, 10 times. But here, if it is in gradient, if it is 10, then it is I plus 20j, 20 times. Means if this is the position vector, then gradient vector is even sharp. Okay, let's take when x equal to 100, then I plus 200j, more or less it is vertical one. So as we grow, then gradient vector is becoming, let's take x equal to 0. At that moment, the gradient vector is I. If that is the case, then it is like this. At 0, gradient vector exactly in the horizontal. Looks like, if so, what we are seeing now? If I have an algebraic equation of a line, then with that algebraic equation, if I calculate the gradient vector, if I'm calculating the gradient vector, then algebraic equation is considered as displacement, net collection. Okay, displacement is a relative term. If displacement, if displacement, if displacement is velocity, if displacement is velocity, then its gradient becomes acceleration. If the gradient is acceleration, then its integration is velocity. If velocity is the net collection, then its rate of collection is acceleration. So this is a relative term. Displacement, we don't consider that pure, pure displacement. Anyway, now if I have algebraic equation, from this algebraic equation, if I go with the differentiation, with algebraic equation, if I go with the differentiation, with algebraic equation, if I go with the differentiation, then it gives me gradient vector. That gradient vector is exactly perpendicular to the curve. Exactly. But if I represent this algebraic curve with a position vector and then calculate the gradient of the position vector, then it is along the curve, tangent. Can you see this? Amazing, right? If I have a vector, if I have algebraic equation y equal to x square and x square minus y equal to 0, x square minus y equal to 0, then gradient vector is exactly perpendicular everywhere. But same thing, y equal to x square, same thing if I say xi plus x square j, xi plus x square j in position vector, and if I calculate gradient, then it becomes plus I plus 2xj. Then the gradient of a position vector, if I represent algebraic equation into position vector, then its gradient become tangent to the curve. One side it is perpendicular to the curve, other side it is tangent to the curve. So I plus 2xj, which is gradient for the position vector xi plus x square j, at x equal to 0, we saw it is only I. So at the beginning it is tangent because it starts like this, y equal to x square, but slowly it becomes like this. At the end it becomes completely vertical. So this is what we have seen. So this is the story of the gradient. So what is how other way it is important? If you have an algebraic equation, can I represent algebraic equation? Can I represent algebraic equation in form of vector? Certainly you can do. If you calculate the gradient vector, if y equal to x square, then gradient vector y equal to x square, then dy by dx equal to 2x. These are not probably mentioned in every book. I won't say it's not mentioned in any book, but not in every book. Why this gradient vector is important? Anyway, if it is gradient, then it talks about rate of change. Certainly. If gradient is 0, means rate of change there is 0. Means it is extreme point, minimum or maximum. But at least at every point, gradient talks about the rate of change. That is why gradient is. So if I have gradient vector, then how it would change, that we will see. Now let's say that if I have an algebraic equation y equal to x square, and algebraic equation does not have any direction, it is set of points. If I want to convert it to vector form so that we will get the direction also, then y equal to x square, if I want in vector form, then it is dy by dx, that is 2x. 2x. Now in vector form, I take x as 1. If x is 1, then y is 2x. That is considered as kind of gradient vector. So I plus 2xj. Simple. dy by dx equal to 2x. If dy by dx equal to 2x, let's set x equal to 1. So I plus 2xj. I plus dy by dx j. That is this is our representation. This is kind of velocity vector or vector field. I plus 2xj. Now let's integrate it with x. You will get back the vector representation of the line. So I1 integration is xi and 2x integration is x square j. So the kind of the representation of y equal to x square curve as a position vector or in vector form is xi plus x square j. Or consider there is a line x plus y equal to 1. X plus y equal to 1. Y equal to 1 minus x. dy by dx equal to minus 1. This is our way. This is more promptly I can say. Dy by dx equal to minus 1. If that is the case, then vector field of this curve is this line x plus y equal to 1 would be I plus dy by dx j. Okay, you can find like dz by dx also full-fledged in any number of fields, any number of fields, any number of feature in machine learning. So if I have y equal to, now representation of x plus y equal to 1 in the vector form, in x plus y equal to 1 in the vector form is I plus dy by dx j, I plus minus 1 j, I minus j, I minus j. If I if I integrate it, then it becomes xi minus xj. I can take out x because vector, the if I look in for the direction, not the magnitude, then x doesn't matter. So the vector representation is I minus j. Okay, if I take the unit vector also, then both will be same. I minus j, unit vector is I minus j whole divided by square root of 2. Xi minus xj, unit vector is xi minus xj divided by square root of x square plus x square. 2x square, x would come out, and then again a story is same, I minus j by square root of 2. Unit vector, we talks about unit strength of the vector and only the direction. So nicely, gradient vector is important. So if you have algebraic equation and you want the vector representation of algebraic equation, if you have algebraic equation, from there vector representation of algebraic equation, then first get the gradient vector of algebraic equation and do the integration back to get back the vector representation of algebraic equation. Not only that, we will see many other usage also. We can have curve length. Curve length. What is the curve length of a circle? Can anyone tell me? If I tell you that the equation of circle is x square plus y square equal to a square, x square plus y square equal to a square, then can someone tell me what is the curve length? What is the circumference of a circle? If I have a sphere, what is the surface area of the sphere? Gradient vector is big thing. Okay, who becomes master in gradient? There is a limitation also. That also we will talk in gradient vector. Who becomes master in gradient vector? He becomes master in correlation between different different coordinate system, calculus, vector and algebra. All four, what is the correlation between them? He becomes master in that. So gradient vector is very big thing. Anyway, two things we have seen in 2D area. In two-dimensional area, two things that we have seen. First is, if I have algebraic equation, then if I calculate gradient vector, then gradient vector is perpendicular to the curve. This is what we saw. And if I represent this algebraic equation in position vector, then gradient vector is tangent to the curve. This is what we have seen. Now concept is like, what is gradient vector of x plus y equal to 1? X plus y equal to 1. What is the gradient vector? Anyone would ask. Gradient vector, let's differentiate it with x and let differentiate it with y. Then gradient vector is I plus j. X plus y equal to 3. Then gradient is I plus j. If that is true, then if this is x-axis and this is y-axis, then x plus y equal to 1 is like line like this, where 1 is intersection on x-axis and 1 is intersection on y-axis. Then gradient vector is I plus j, is exactly perpendicular to this line, I plus j. So gradient vector is always perpendicular to the algebraic equation. This is what we keep saying. What is the problem here? Can anyone see problem? So nicely we are demonstrating, right? Y equal to x square, then x square minus y equal to 0, and then gradient vector is, well, boss, you have to do some meaningful differentiation, right? If you talk about algebra and calculus, then calculus does not know x square plus y square plus z square equal to 0 and you differentiate. This is not the calculus. Calculus is pure function over independent variable. You can say my independent variable is x-axis, my independent variable is y-axis, my independent variable is xy plane, my independent variable is xyz cube, whatever it is. But you have to have a function over set of over an independent variable. Independent variable can be a line, means one variable. Independent variable can be a surface. Independent variable can be a cube, or independent variable can be a set of 50 variables, whatever it is. But it needs a function over an independent variable. That is calculus. If I say I have equation x plus y equal to 1, then immediately it will ask which is independent and which is dependent. Don't tell me x equal to x plus y equal to 1. I don't want your line and graph equation. Calculus has nothing to do with your line and graph equation. You tell me what is your independent and what is dependent. Okay, I'm sorry. Y equal to 1 minus x. Fx equal to 1 minus x. Talk like that. Okay, what do you want? Then I want dy by dx. Then it is 1 minus x is minus 1. That's it. But what we are doing is x plus 1 equal to 1, x plus y equal to 1, then gradient vector is I plus j, 1, 1. These are this does not work in calculus. This is whatever we are going to talk now, it is not available in any of them. That's why whatever lecture lecture we are giving, none of them is available in any of them. All are, I have seen personally, best book also, everyone is copying from here and there. That's it. You find an example in a very good book, but slowly you will see that is available in Wikipedia. If you find something new in Wikipedia, then it is available in some other one. Everyone is copying from here and there. I guarantee what I am going to say, it is not available in any of the books. Means everything has a protocol, everything has a nomenclature, everything has a rule and regulation. If x plus y equal to 1 is good algebraic equation, but certainly it has nothing to do with calculus algebra. Calculus algebra talks in independent and dependent components. Straightforward. Y equal to 1 minus x, fx equal to function over x equal to 1 minus x. This representation is required in the calculus. So then you can calculate the gradient vector. Not x plus y equal to 1, and in parabola I took y equal to x square, so x square minus y equal to 0. In circle, x square plus y square equal to a square. So a gradient vector is 2x and 2y, 2xi plus 2yj. Parabola y square x square minus y equal to 0, so 2xi minus j is the gradient vector. What is gradient? What is calculus? What is algebra? What is numeric science? What is vector? What is different coordinates? What are those? Everyone sits in its own universe. This is what better I would say. Everyone sits in own universe. If x, y, z is orthogonal in Cartesian coordinate system, then these technology are again orthogonal to each other. They are not related to each other. They use others, but they have their own way. Vector has its own way, and then vector which has a direction and magnitude. That's it. If I say my vector is xi plus xj, then it is combination of two vectors xi and xj, two energy that are colliding at origin. One is xi flowing in I direction and one is xj flowing in j direction. Its magnitude is dependent upon variable x, that is different thing. But two different vectors, if they get collide at origin, they go in xi plus xj direction. Then coordinate system, Cartesian coordinate, polar coordinate, then you have cylindrical coordinate system and spherical coordinate system. They are themselves orthogonal. Means we will see in machine learning, we will see Bayes theorem, pioneer. From Bayes theorem, actually machine learning enters. Okay, what is machine learning? What is artificial intelligence? Artificial intelligence, machine learning are nothing but Bayes theorem. What is calculus? Calculus is nothing but integration. From there it begins. From there it enters. Okay, okay. Like means I should not digress from what I am discussing. Like there is a spiritual book, religious book in India called Gita. There is a religious book. I am not kind of associating it with Gita and dissociating with other. I have not read those books. Every religion is same only, exact. I won't say copy paste, but exactly same. Only language differ. That's it. So in Gita, the Arjun asked to Krishna that how he, how you entered into the universe. This is the question he fires. That how you when Krishna shows his the kind of Vishwayapi Roop, means universal body face, where he has four hands, and in one hand there is a lotus, and then in one hand there is a shankh. I don't know what is English of shankh, this Sanskrit word, and four hands. When he saw in Krishna, then only the first question he fires is, you are so powerful, you are so magnificent, then how you entered into the universe? Because this universe look smaller to you, then how you entered? Okay, I mean, I think I did little bit mismatch. He asked how you entered into universe. Then he shows his actual Vishwayapi Roop, that is four hands, and he entered into universe with this shape. In one hand lotus, and in one hand shankh, like that. This is how he entered into the universe. So idea is that where technology enters. So in machine learning, the technology enters. Machine learning technology, if we see this is the universe, then where is the entry point? Then if you try to enter into machine learning, they have to enter through Bayes theorem. If you try to enter into calculus, then you have to enter through integration. If you try to enter through coordinate system, then you have to enter through Cartesian coordinate. So these are the fundamentals. If you try to enter into mathematics, then you have to enter through addition. Everything is kind of expansion, the upgradation of the kind of addition only. So everything in calculus is kind of expansion of, I don't know what is the best English word. So in Sanskrit it is vistaram, vistar. So everything is expansion of integration only. So in machine learning, everything is expansion of Bayes theorem. We are thinking of writing a book that how Bayes theorem is highly deeply related to the deep learning, that is neural network. People generally, if they see neural network, they start thinking in matrices and here and there, and then input layer and hidden layer and output layer, and then matrix multiplication, and you have to fill up the matrices here and there, and you are done. Since your full data structure is filled up, then you pass any input and you get the output through the data structure. But hidden the scene, hidden in the hidden layer of a neural network, you have Bayes theorem. On top of Bayes theorem only, everything comes into the picture. So everything we will talk. Oh, so now we are talking about the kind of gradient vector. So if you have algebraic equation, then in calculus, I think we did took digression. So calculus, when we talk about calculus, then calculus works through algebra. But algebra has to be in independent and dependent component. So if I talk about x plus y equal to 1, if that is the equation, then it is y equal to 1 minus x. This is 2D. But I am saying x plus y equal to 1 and quickly calculate the gradient as if it is 2D y equal to 1 minus x, then its gradient is minus I. That's it. But my gradient is x plus y equal to 1. The gradient is I plus j. If that is the case, then this is hinting towards three dimension. It is hinting toward 3D. X plus y equal to 1 is 3D, not 2D. X plus x square plus y square equal to a square. If I calculate the gradient, if it is still algebra, then it is fine. It is equation of a circle. But if I calculating gradient as 2I plus 2j x square plus y square equal to a square 2xi plus 2yj, then it is 3D. Because if it is 2D, then y equal to square root of a square minus x square. If I calculate dy by dx, that is the gradient, it will have only one direction, that is I. If I have a line x plus y equal to 1, y equal to 1 minus x dy by dx, that is the partial derivative or gradient vector, then it has gradient only along I direction. That is 2D. If x plus y equal to 1 and gradient vector is I plus j, then it is 3D. If x square plus y square equal to a square and gradient vector is 2xi plus 2yj, then it is 3D. What is 3D? 3D is nothing but you have in 2D the independent component is x-axis. In 2D, independent component is x-axis. In 2D, independent component is x-axis. In 3D, independent component is xy plane. XY plane. This plane has x-axis and y-axis. This plane has y-axis and x-axis. But independent component is xy plane. People say that in 3D, the independent component is multivariable. There is nothing called multivariable. We will write book on this. There is nothing called multivariable. There is single variable. Either independent component is x-axis or independent component is xy plane or independent component is xyz cube or independent component is xyz alpha, whatever it is. That's how machine learning comes into the picture, where you have 10 number of feature. If it is 10 number of feature, then there is one independent component which is of dimensionality 10. And then the function over this independent feature is the output target. If there is one independent component, that is one feature, and that if I call it x and then target is y, then y equal to fx. If two independent components are there, x and y, then target is fxy. If independent component is xyz, then target is function over xyz. Something like this. We will talk more on it. Something like this. So anyway, now if we go to 3 dimension, then I have xy plane as independent component. If xy plane is independent component, if xy plane is independent component, if xy if xy plane is independent component, then I have a sphere on top of it. This sphere had surface. This sphere has surface. Under this sphere, if I drop this sphere on the xy plane, and then it will have a circle. So if I take point on the circle, if I draw a circle, if I map the 3D on this surface, and if it draws a circle, then my xy point, if I take on this circle somewhere inside the circle, then it would map to somewhere in the surface. Understandable, right? If this is xy plane and this is a sphere on top of xy plane, every point in the xy plane, if I take, then some point it will pass through. It will not hit the sphere, but some of the xy will map to some point. So I can say that function over x and y, function over any point x and y would result into the vertical component. If x and y is at center 0, 0, then function over x and y, function over x and y can have some scalar value. So it is here. Function, if xy is 1, 1, then it is at height this. fxy has some value. fxy, whatever value we are saying that is orthogonal to this plane, means in the vertical plane. If I take all the xy value and if I connect, then it becomes a sphere. So for many x and y, the whatever value we are getting, that is not defined if I have a function over sphere. Function fxy is a sphere. What is the equation of sphere? If I see algebraic equation, then it is x square plus y square plus z square equal to a square. But if I talk in calculus algebra, then it is fxy equal to square root of a square minus x square minus y square. Both are different. I mean, different way in representation. So when we talk about calculus algebra, then fxy equal to square root of a square minus x square minus y square. If that is the case, then z equal to square root of a square minus x square minus y square. If I take any value of x and y, since x and y are independent to each other, I am free to take any value x and y. But I cannot take any value in x and y where x square plus y square goes beyond a square. Okay, if I do that, then a square minus x square minus y square, a square minus in bracket x square plus y square. If x square plus y square go beyond a square, then it will become imaginary number. A square minus greater than a square will become, a square will become imaginary number. So expectation is that choose x and y so that x square plus y square equal to or less than a square. If that is the case, then set of point I take in x and y, for that whatever z I am seeing, if I connect all the z point, it becomes a spherical surface, a ball. Okay, so z equal to square root of a square minus x square minus y square. This is calculus. Algebra is a square plus y, x square plus y square plus z square equal to a square. Calculate the gradient. 2xi plus 2yj plus 2zk. This is not calculus. Z equal to square root of a square minus x square minus y square. What is the gradient? Dz by dxi, dz by dyj, dz by dxi plus dz by dyj. That is the actual gradient vector, whatever is. We will see it. So now let's consider that I have a equation, line equation. You remember that we showed a line equation, x plus y equal to 1. If I say this is 3D, then equation of 3D is z equal to x plus y. If that is the case, then we have taken z as 1. Z as 1. If that is the case, then x plus y equal to 1. What it is? Okay. Now consider that this is xy plane. Consider my hand, the way I am blowing, whatever I am doing. So this is xy plane. If this is xy plane, then there is a surface that is on top of xy plane. Consider this surface is landing on the xy plane. So xy plane and the surface are coinciding. Okay, now there is a slope in the x direction, that is dz by dx is 1. So it is like this. Now if I keep this x-axis is constant, and then if I make slope like this, then dz by dy is also 1. Can you see now? There is slope of in x direction and there is a slope in y direction. So dy by dz by dx equal to 1 and dz by dy equal to 1. If that is the case, then what is the equation of surface if it is passing through the origin? Then z minus z0 equal to dz by dx x minus x0 plus dz by dy into y minus y0. If that is the case, when dz by dx I have taken slope as 1 and dz by dy slope as 1, then equation of surface is z equal to x plus y. X plus y. Now if I take any x and y, x equal to 1 and y equal to 1, if this is xy plane and this is the surface, then in xy plane, wherever this is xy plane, if I take x and y as 1 and 1, and if I draw a vertical line, then it will hit at one point of the surface. If I keep changing x and y and then draw, it will be a surface. That is z equal to x plus y. Z equal to x plus y means y 0 0, then z equal to 0. Height is 0. At that point, x comma y 0 0, height is 0. If x comma y is 2 and 2, then height is 4. If x comma y is 0 and 2, then height is 2. If x comma y is 2 and 3, then height is 5. All the height, if you take as points and if you connect, then it will become surface like this. So this is equation of the surface z equal to x plus y. What is contour? Contour means what is a cross section. Cross section means, I think this is hi-fi term. Let's consider z is 1. Z is 1 fixed. Z is 1. Then what is the set of xy point that will satisfy z as 1? Then if x is 0.5 and y is 0.5, then z is 1. Someone will say, if x is 0 and y is 1, then again z is 1. Someone will say, if x is 1 and y is 0, then again it is 1. Someone will say, if x is 0.75 and y is 0.25, then again z is 1. If you take set of all x and y points where z is 1, that will land up in xy plane as a straight line. That is called contour line. Contour line, if this is xy plane and there is a surface on top of xy plane is like this, and if this is xy plane, if this is xy plane and this is the height of 1, this is the height of 1, then at one height if I make a cut, okay, if this is the case, at height of 1, if I make a cut, this surface is a flat surface. But if surface is like this and it is like this is the surface, at height 1, if I make a cut, it will cut a line. Understandable, right? If there is a sphere and if I make a cut, then there will be a circle. If there is a surface like this and this is a surface. If you make a cut at z equal to 1, a cut through a surface, not through a line. If there is a surface that is z equal to 1, that is, if that surface is cutting this surface, then it will intersect in a line. The intersection is a line. That line is, if I draw on xy plane, that is called contour line at cross section height z or fxy equal to 1. That line is x plus y equal to 1, where z equal to 1. So if it is 3D, then certainly we will have dz by dx and we will have dz by dy. So what is the equation of actual equation of x plus y equal to 1 is z equal to x plus y. Then dz by dx is 1 and dz by dy is 1. That's why the gradient vector is I plus j. If it is x, if parabola y equal to x square, and if I represent as x square plus y, x square minus y equal to 0, it transforms into 3D, where z equal to x square minus y. Then dz by dx is 2x and dz by dy is minus 1. So gradient vector is 2xi minus 1, same as circle. We'll proceed on this. So gradient vector is very big thing, very big. But certainly this is not the entry point into the calculus. Entry point into the calculus is integration. If you don't know integration very well, okay, we have talked thoroughly about integration in primitive calculus. So if you don't have knowledge about integration, then you cannot enter into the calculus at all. So these are important but little higher level. We will talk in the gradient vector.